The scale of this project defies imagination. Beneath these peaks, thousands of meters of rock separate Europe. This is where engineering meets geology.
The old railway could cross the mountains, but every climb cost speed, energy, and capacity. Instead of forcing trains over the mountain, Switzerland chose to carry them almost level beneath it. Before machines entered the mountain, geologists had to discover what the mountain was hiding. The tunnel would not pass through one mountain material, but through dozens of different geological behaviors. To shorten the schedule, 5 work fronts attacked the mountain from different directions at the same time. At Sedrun, people and machines had to descend deep into the mountain before excavation could even begin. Crews separated by an entire mountain still had to agree on one invisible line. No single excavation method could defeat every section of the Alps. After years of planning, the mountain was finally about to answer back.
Keep an eye on the load. Right, watching it. Hydraulics are holding steady. Good. Let's maintain this pace.
Every advance depended on the machine gripping the mountain itself.
Not every section of the Alps could be conquered by the same method.
Secure the bolts. Done. Final check. Clear out. Everyone retreat. Let's move.
The tunnel became safe only after the mountain was supported. The measurements confirm a complex fracture zone here. We need to reinforce it immediately. Geology, not schedules, made the final decisions.
The temperature is spiking. Check that middle ring. Looks worn. I'm marking it for replacement. Yeah, grab the thermal scanner. The cutter head has slowed. Sensors are picking up a significant complex geological fault. We need to analyze these rock samples immediately.
Before every meter forward, engineers searched for hidden water. Preparation prevented a dangerous surprise from becoming a disaster. Lock the pipe in place.
Secure the clamps immediately.
Now, we manage the flow.
Ensure the sealant fills every gap. Check the tension on the mesh here. Verified. Proceed with the final inspection on the east wall.
Keep it steady. Watch the loose piece. Move it slow. Check that cap rock above. Clear on the left. Bring it down. All clear. Bring it out.
Accuracy would decide whether 2 tunnels separated by mountains would ever meet.
Edges. The mountain range presents a unique challenge, requiring precise measurements from both teams.
Our surveys confirm the redundancy.
Sometimes the mountain wore down the machine faster than expected.
Okay, hydraulics are stable. Engaging cutter head now. Perfect. Resuming operations.
Thousands of people were solving one engineering problem from many different directions.
The mountain is stressing. Get back. Everyone fall back to the safe zone. Watch that left wall. Hurry. We need to pull the machine. The stress test results match the new heading. Yes, the data aligns. Let's install the thermal sensor here. Seismic sensor secure and live.
The readings are stable. Visibility is clear. The system is working. Let's keep it moving. Roger that.
The cutter head was only the beginning of an entire underground factory.
All right, crew. Safety briefing complete. Gas levels good. System check confirmed. Ready to resume, John. Engage the cutter head. Let's dig. Line it up. Slowly. Perfect. Secure it. Looks good on the tablet.
Check the pressure gauge on the hose. Make sure it's stable. Looks good, right on target. Let's adjust this sensor before we resume.
Thousands of coordinated operations had to function as one. The deeper they traveled, the greater the mountain's challenge became.
The deeper the tunnel advanced, the more carefully every movement of the mountain had to be measured.
Hard rock demanded patience, not speed. Every worn cutter had to be replaced before the mountain stopped the machine itself. A tunnel this long required its own underground transport network.
Checking Monument 6.
Confirm measurement.
Reading 356.12.
Independent verification matches.
Millimeters determined whether two excavation teams would eventually meet.
The stress test confirmed the fault line here, marking that in the record. The next charge needs to be precise. Exactly. Let's align the drill pattern now.
Hundreds of operations had to stay synchronized every hour.
Main systems are online and green. Com checks complete. Ventilation is optimal. Secure the refuge. Let's head back to the bore.
The mountain constantly forced engineers to adapt. The probe indicates a fault line. Revise the torque to compensate.
Separated by kilometers of rock, every crew was moving toward the same historic moment.
Sometimes the fastest decision was to stop. No, it's not holding. We need to revise. Copy that. Decreasing rotation speed and adjusting water pressure.
Progress only mattered if the tunnel remained stable.
The engineers redesigned the blast pattern. Position every borehole under survey guidance. Explosives followed engineering, not instinct.
Every minute underground depended on perfect logistics.
Check the bearing clearance on Sector 3. 10-4.
Sector 3, clearance confirmed.
Rotating the cylinder now. Look for the fluid level.
The primary survey results indicate a discrepancy of 2.5 millimeters.
Cross-reference with the laser scan verification.
Adjusting the virtual baseline now.
The airflow needed balancing.
Turn up fan 3.
Dust clearing nicely now.
Maintaining system pressure.
Fresh air became another critical engineering system.
The calculations confirm it.
Yeah.
Yes, they are almost there. This is the breakthrough.
Only a final wall of alpine rock remained between history and success.
Final confirmation complete. Southern heading.
Copy that. Ready for advance.
Northern heading. Proceed.
Precision over speed. Measured alignment with design axis. Check the horizontal and vertical coordinates. Every calculation was checked because history would not allow a second attempt.
The rock appears stable, confirming our assessment. Excellent. Let's move forward. Even near the end, the mountain still demanded respect.
No one wanted a mechanical failure this close to the finish.
Checks complete on the hydraulics.
Main cutter head good to go.
Separated by kilometers of history, the teams were now separated by only meters of rock. The entire underground supply system continued until the very last breakthrough.
The data confirms our final alignment. Yes, it's a perfect match. Years of preparation had narrowed the impossible to one final decision. We did it!
Only one wall remained between two worlds that had been moving toward each other for years. The breakthrough has not yet occurred.
Elevation checks out on grid 4.
Confirmed. Alignment matches. Final variance point holding steady.
Authorization requested.
Requesting authorization.
The machine advanced carefully because there would be only one first breakthrough. High vibration at the cutting face.
Parameters confirmed.
Structural integrity verified. All clear. Initiate sequence.
The structure is holding. Data confirms integrity. Light is increasing rapidly.
For the first time, two teams separated by an entire mountain could finally see each other.
Readings are perfect. We've met tolerance. Exceptional. Confirming now. Looks spot on. Great work, team.
17 years of engineering had reached its defining moment.
Thousands of separate engineering decisions had become one connected achievement. For the first time, the mountain had been crossed from within. Breaking through the mountain was only the beginning of building a railway. Excavation was finished. Building a permanent railway had only just begun. Every drop of groundwater needed a controlled path away from the railway. The tunnel had to remain stable, not just for decades, but for generations. The future railway would rest on extraordinary precision beneath the mountain.
The tunnel would eventually carry far more than trains.
The cross passage is completed. The emergency doors and installations are secure.
The two tunnels are now one safety system.
Invisible systems would protect every train entering the Alps. We need to check the circuit integrity.
Confirmed. Section Delta 4 is wired correctly.
Alignment check good. Initiate fastening.
Roger that.
Secure the bolts.
Elevation and gauge checked. Looking good on this section.
Aligning rail 7. Slight adjustment needed.
Crane, lower, slow and steady. Perfect.
Hold it there. Okay, reading. Adjust left.
Got it.
Verified. Good to go. Roger that. Right there. Lower it down. Millimeter to the left. Check the tension.
Thousands of hidden connections would eventually move every train safely through the mountain.
The cable is ready for the connection. Yeah. Just need to secure this unit. Testing the emergency line. It's clear.
Every system had to function together before a single train could enter.
Yeah.
Status check, electrical stable, ventilation active. Proceed with communications test.
The data matches the design specifications.
Confirming overhead clearance within tolerance. Construction ended with measurement, not celebration.
The alignment is off by 3 millimeters. We'll correct it now. Verified. Perfect. 17 years, and it's finally ready. Here it comes.
Before carrying people, the tunnel had to prove itself. Acceleration looks stable.
Electrical systems are green.
Signal reception holding strong. The world's longest railway tunnel was no longer a construction site. It was becoming part of Europe's future.
Drainage system clear on the left side.
Confirmed. Adding to the record.
Check the cable routes at the 500-meter mark.
Roger that. It looks secure.
The tunnel finally received the energy that would move trains beneath the Alps.
Voltage stable. We have traction.
Solid confirmation. Control. Power's flowing.
Safety depended on thousands of invisible decisions happening automatically.
Confirmed.
Route setting. Train detection is active. Communicate.
All personnel, proceed to cross passage 1. Move them to the left. Confirmed. Cross passage 1. Maintain a steady pace. Check the perimeter before clearing.
Every emergency procedure had been engineered before it was ever needed.
The world's longest railway tunnel would now be managed as one integrated system.
The thermal imaging looks clean, no hotspots. Track geometry shows minor deviation on curve 4, adjusting tolerances. Verified, implementing the update now.
The tunnel was no longer being built, it was being proven.
The evidence shows the results are verified, and with that, final certification is complete. Years of construction ended with engineering evidence, not assumptions.
The impossible engineering challenge was finally ready to serve Europe. After 17 years, the world's longest railway tunnel was finally ready to connect Europe. Freight was among the first to benefit from a faster route beneath the mountains. Passengers could now cross beneath the Alps without climbing over them.
The tunnel was designed not just for speed, but for reliability.
The laser indicates a deviation here. All right, check the drainage and catenary systems next. On it.
Instead of replacing history, the new tunnel reshaped the future. One engineering project strengthened an entire European transport corridor. Most travelers never see the engineering hidden beneath the mountains.
Keep an eye on the sensors. Noted. It's flawless.
What once seemed impossible had become part of everyday life. The opening ceremony ended. The engineering responsibility never would.
Measure the rail gauge and super elevation precisely. Verification confirmed, data logged. Proceed to the next section. Every measurement matters.
Testing. Check 1, 2, over. Roger, loud and clear. Safety was engineered into every connection beneath the Alps.
Great infrastructure succeeds when it becomes invisible to everyday life. 17 years transformed raw rock into permanent infrastructure.
The stress analysis confirms stable conditions throughout the lining. Excellent work. We're showing peak performance on the pressure gauges here.
The tunnel changed engineering long after construction had finished. Millions would trust a structure they would never truly see. The greatest victory over the mountain left the mountain almost unchanged. Every day, trains crossed the Alps in minutes through a tunnel that took nearly 2 decades to build. The engineering challenge may be over, but the responsibility continues with every passing train.
The greatest part of the project cannot be seen from the surface.
Thousands of engineering systems now work together every second.
The overhead alignment looks good.
Verifying the comms connection now.
Received and confirmed. All systems green.
Every element inside the tunnel serves one purpose: reliable operation. Knowledge gained beneath the Alps continues to train the next generation of engineers. What was once dust, noise, and uncertainty has become quiet precision. Sometimes the greatest engineering leaves almost no visible trace. The Alps did not become smaller. Human determination simply found another way through.
The greatest engineering achievements often begin to disappear the moment they become part of everyday life.
Every passing train is the result of millions of engineering decisions made years earlier.
Drainage looks clear on Sector 7. Green light on alignment, we're good to go. Solid, another perfect run.
The mountain remained. Humanity simply learned to pass through it. Every stage depended on the one before it. Engineering is never a single moment. The tunnel is quiet now, but every meter remembers the work that created it.
Thousands of people solved one impossible problem together. So, how does it look? It's solid. Good work, everyone.
The mountain has not changed. Our understanding of it has. Some of humanity's greatest victories are hidden beneath our feet.
Engineering is more than concrete and steel. It is the courage to imagine a path where none existed before.